Hello friends, this is Durga from ITversity/Technology Mentor, and currently we are talking about setting up MRv1 with the job tracker and task tracker. We have already seen how easy it is doing that using management tools like Cloudera if it is supported. And once you have set it up, whatever version you are using and how you are set it up, you have to validate by running some MapReduce programs. Otherwise, you will hit surprises once the environment is turned out to the development team. It is not only with respect to Hadoop administration. Even if you set up a Oracle database or a WebLogic application server or any software product that is deployed for development or testing or production usage, it's always a good practice to validate as much as possible before turning out to the respective stakeholder. So that being said, we have already set up MRv1 in the last video using Cloudera Manager, and now we will try to validate that. So my Cloudera Manager is running on the VM, and I'm trying to, instead of connecting through terminal on the VM, I'm trying to connect using my terminal on my Mac using SSH command. And Cloudera VM comes with a user called Cloudera. It's always better to use that. And you can get the IP address of your VM by running ifconfig-a, and using this IP address you can actually connect to the VM. And once it prompts for the password, you have to enter Cloudera if you are using Cloudera VM, if you have not changed the passwords. And I have already copied data and training.jar file here. So all my data is under this, and the jar file is under this one. So we will be running. So this jar file actually contains the programs which I have written to process cards data, which I have shown earlier at the beginning of the MapReduce series, and also the data which is copied when we spoke about HDFS. So first let us validate this jar file, what all programs we have. For that you can run jar tvf and the jar file, and it has a bunch of them. And we were talking about card count by suite when I actually demonstrated about or explained about MapReduce concepts. So we will try to run this program and see the results. Okay. That being said, I also have the data directory here, and I have cards data which I have to copy to HDFS. So I have validated that one, and in HDFS it is empty for the user space of Cloudera. There is no folders or files. So I am just copying the entire directory of cards, and if you look at cards, there are several files, and let me copy only large deck.txt deck of cards. I don't want to copy others. So for that I have to first create the directory by using mkdir command under the user space Cloudera, which is owned by this user Cloudera. And here I want to create a directory called cards. Hit enter, and then I want to just put deck of cards. Okay, it's under cards dot, and also large deck to user Cloudera cards. And the files are copied: Hadoop fs-ls user Cloudera cards, and you can see those two files. And also if you want, you can run hdfs fsck, and path is user Cloudera cards. This is the path I want to run fsck command. Files, blocks, locations. So as we have only one node, the replication factor is 1, and we have two files. One is deck of cards, which is only 693 bytes, which fits in one block, so there is only one. And for the other file, there are three blocks. Two of them are with 128 MB in size, and the last one is of 92 or 93 MB in size. So we copied the data. Now we will run this program. Training 0.01 snapshot.jar, and we will try to run card count by suite program, which is under package called training demo cards. To run any MapReduce job, you have to use Hadoop jar command. Earlier we have seen Hadoop FS to deal with file system. Here Hadoop jar is the command which will actually let you run the MapReduce applications. So if you see, you have to give Hadoop jar and then jar file name, and then you have to give the main class if it is not a runnable jar file. If it is a runnable jar file, you just need to pass the jar file. That's why it is in the square brackets. Whenever this is a I forgot the notation. This is some standard notation where optional parameters will be shown in square brackets. And in this case, if your jar file is a runnable jar file, you don't need to give the class name. You just give the Hadoop jar file name and parameters. In this case, it's not a runnable jar, so I have to give Hadoop jar training 001 snapshot.jar, and then I have to give the class name. In this case, it's training.demo.cards. Card count by suite, and then I have to give the input path. So the program takes two parameters. It is written by me, and it accepts two parameters. One is input path and the other one is output path. So our input path is user cloudera / cards / largedeck.txt, and my output path is, I have to give a new path which does not exist, otherwise it will fail. That is the typical behavior of MapReduce programs. Cards output, let me say large deck output, card count by suite output. And now the job is running. As this says, it is trying to process one file. That's why it says total input pass to process is 1. If you have multiple files in the path, if you are giving directory instead of the complete path, including file name, if there are multiple files, you will see number of files here. And then the MapReduce program is running. The program will complete in a moment. So while running, I will try to run it again. While running, you can actually go to here and refresh it, and you can actually see that job is running. And let me zoom in. How to zoom this one? Okay, view, zoom in. Okay, let me run this program again with suffix 01 so that it will actually create a new directory, otherwise it will fail. If I give the same output path again, it will fail. Now if I refresh here, you can see that job is running. You can click on this to keep track of it, and also you can go to command line and you can run mapred job list. Job list will show you currently running commands. So there is only one MapReduce application that is currently running, so it shows only one result. And then you can see additional information by running mapred job and if you hit enter, it can give you a lot of details. So you can actually check MapRed job status, and it takes job ID as parameter, and in our case job ID is this one, 0002. So this is very important. You need to know all these things because you might have to kill the jobs. So you should know how to kill the jobs. First, you have to run MapReduce job list command to list all the jobs and determine if there is some hanging job, and if you want to kill it, you have to get the job ID, see the status, and then run MapReduce job -kill, give the job ID, and the job will be killed. Okay, so once the job is run, whether it is job tracker UI or even in web console, when you check the status, you can see this some very important information called as counters. So counters will give you a lot of insights about how the job being ran. So if you look at the counters are categorized into multiple things. One is file system counters, second one is job counters, third one is MapReduce framework. Okay. In case of file system counters, it will tell you how much data is being read and how much data is being written. So you can estimate the amount of IO that is being happening by looking through file system counters. And job counters, it will tell you how many map tasks have ran, how many reduce tasks have ran, and how many of those map tasks are data local. So if you remember this picture, we have block 1, block 2, block 3 on 3 different nodes, and there is a chance that the map task running on a different node try to process one of these blocks. For example, a map task that is forked on node 2 might process block 1 or block 3 if there is no capacity on the other nodes to process that block at that time. In that case, you will see this number, data local map tasks, different to the launched map tasks, and it should be at least 98-99%. There shouldn't be many tasks that are not data local. Okay, so this is a very important parameter to determine if there are any issues going on, and this can significantly decrease the performance, because if map task is running on a different node than where the block is, then it has to do the network IO, and if too many are running like that, it can easily saturate the network, and you will see major issues. And then MapReduce framework, how many input records are there? So there are 27 million records. So the map function will be invoked 27 million times. And this how many map output records are there? And I have not spoken about combine, so don't worry about this. Combiner is also a very important concept, especially when we are talking about aggregators. But this is the important one, as we are trying to do card count by suite, and we have 4 keys: club, spade, heart, and diamond. The input groups are 4, and output records are 4, because we are actually doing count group by suite. And now we will see the output of the data, output of this job. So you can actually do Hadoop fs -ls user Cloudera, and then card count by suite output 01, or you can even look at the previous one also. We ran the same job twice, and if you see, it has created 2 files because the number of reducers are 2. That you can determine by looking at job counters. The launched reduce tasks are 2, but we have 4 keys. So the number of reducers 2 is actually computed by Cloudera behind the scenes. By default, the MapReduce APIs uses it as 1 only, or I might have hard coded in my program. Either I would have hard coded in the program, or it is set by the Cloudera behind the scenes. Irrespective of that, When we run the job, just understand that this job has run with 3 map tasks and 2 reduced tasks. As it has run with 2 reduced tasks, you can see 2 files created, and you can do Hadoop fs minus cat minus user cloudera part star, and you can see that all spade, club, diamond and heart are 6,815,744. And apart from these 2 files which starts with path minus r, you see a directory with name underscore logs. So if you see, this is a directory. So it might have some logs in them. Let us see. Yeah, it has another directory. Okay, once the job is completed, the logs will go to the history. I think that's what the directory is, and it has the XML file. This XML file is very important, because if you remember, we have a bunch of XML files. One is coresite.xml, second one is hdfsite.xml, and then MapReduce.xml when we added the MapReduce, and all these have many parameters. And also, as I have explained, as part of HDFS videos, we can override certain parameters or any parameter by passing minus capital D when you run Hadoop FS, or it works even with Hadoop jar. So we don't know what parameters are in effect until we open this file. This file is very, very important, and especially for troubleshooting the issues. Most of the scenarios, you should go to your job tracker UI. In this case, you can actually access it using your PC also rather than on VM. So I am using the browser, http:// and the port number for our job tracker is 50030, and hit enter, and you can actually see the same output here. Okay, and when you click on this job, you can see the XML file here, and you can click on this and it will give you all the details at runtime. You can search for a particular parameter like dfs.replication, and the replication is 1 in this case. So like using this, you can actually see whether the desired parameters are as per your expectations while troubleshooting the issues. It will give a lot more information than this, and it will help you quite a bit while troubleshooting the issues. That being said, we are almost done with our MRv1. We will close with important parameters in MRv1 or Classic. So these are the important parameters: job tracker with 8021, and job tracker web interface with 5003 with 0 port number. And then there are some directories like MapRed system directory, which uses to store MapReduce control files, and MapRed.local directory. So when we are actually running the MapReduce job, there will be a lot of intermediate data that will be generated. So the map output is an intermediate data, and it has to before passing it to the reducer, it has to be maintained internally, and that location is controlled by the parameter called MapRed.local dir. And then there are different types of scheduler. As I mentioned to you, multiple jobs can or multiple applications might be running on the cluster at the same time, and they have to be scheduled in particular fashion to run effectively. So for that, there is a parameter called MapRed job tracker task scheduler. There are three types of schedulers: FIFO, FAIR, and capacity. We will see those things later. And then there is a concept called MapRed queues. You can create multiple queues to set and also set priorities for them. So for example, you can have a queue for production with higher priority over queue for testing or development with which will have lower priority than production. There is a default queue, so everything will go to that queue unless you specify at runtime which queue it should run. And then MapReduce tasks. It is reduce tasks per job. In the MapRed site.xml file, by default it is 1, but when we actually see when the job is ran, the number of reduced tasks are 2. That means it is overridden somewhere. Either it is in the program or Cloudera might have overridden that. Most likely it is part of my program. And then MapRed task tracker maptask.maximum. So each task tracker will control map tasks and reduce tasks. So you have to set these parameters to tell how many map tasks should be running on a given node which is designated as task tracker. Most likely all the slaves will be task tracker. So these parameters will control how many mappers should run on all the nodes in the cluster which have task tracker in them, and how many reduced tasks should run on each and every node in the cluster. So this is maximum map slots per task tracker, which means wherever task tracker is running, those many map slots should be allocated to that. So these two are predefined. So at times the disadvantage of predefining the map tasks and reduced tasks is that your cluster might be overutilized or underutilized depending upon the kind of jobs you are running. So it's a performance tuning concept, and we will see somewhere else about how to determine these things and how to play with map slots and reduce slots to effectively use the cluster. That being said, we have seen everything, and also one more thing you need to understand is once the logs of the map tasks and reduce tasks. So we went to the job, and the job is divided in the job is completed as 3 map tasks and 2 reduce tasks, and at times we have to see the logs. For that you just have to click that link here or here. It will take you to different page, and here you will get all the tasks listed for that job, all the map tasks listed for that job. You can click on that, and then you will actually see see logs at each task level. So if there are any errors, you will see a link here, and you can click on that, and you will see what the issue is. Otherwise, if everything runs smooth, the informational logs will be here. You can click on this. So it will look like this. For some reason it is not displaying anything here, but typically we'll see a lot of information that is being emitted. So if you can interpret that output, you will understand the framework very easily, and developers should be able to understand that. It means they should be able to understand the errors, and they have to communicate with the developers. But for advanced admins, senior admins, they should also be also able to interpret the logs that are being generated to make important decisions for tuning the performance of the jobs that are running on the cluster. Okay, that being said, that's it. And yeah, we have seen log4j files and all those things. We have seen web interface also. I'm just verifying whether I missed anything. Okay, so there are few more concepts that needs to be understood, and they are not just limited to MRv1 or yarn. It's in general MapReduce, and we will see those things in the next video. Thank you. Bye.